All right. Well, welcome to today's podcast. I'm glad to be hosting this episode and joined by my two distinguished guests. But before I introduce my guest today, just want to kind of, lay the context of the scenario that we're going to be talking about today. So, if you imagine you're wearing, gloves, thick gloves, the kind that you would wear on a cold winter day or as part of your PPE to get your job done. So maybe you're a utility lineman or you're a firefighter or a delivery driver, and you need to kind of keep your hands protected. You're maintaining heavy equipment, or you're in and out of a freezer or cold environment, and you require these thick gloves. And so picture yourself having to wear these gloves, but also having to do your job and requiring a tablet. To perform your tasks while you're wearing this glove. So, well, you get a tablet that has glove touch sensitivity, or maybe your company gives you one. But today, what if I kind of told you that in order to, use your gloves with your tablet that has the glove touch sensitivity, you have to manually go into the settings of your tablet and toggle the glove touch setting so that your tablet can recognize and sense the kind of touch appropriately. So whether it's bare fingers or whether it's a gloved finger, basically. And you can imagine how much of a hassle this would be for you to each time you put on your gloves or take them off, have to repeat the cycle of going into the settings and toggling back and forth. And tablets have been around for a while, and people are probably wondering why it's taken so long to address this really difficult and hassle-prone kind of activity that our frontline workers have to deal with in their workflows as they kind of handle technology and have to do so with gloves. So that's what we're here to talk about today. The glove touch sensitivity, and this new technology that we now have that addresses this hassle for our frontline workers. So, every day for decades, this has been a thing that frontline workers had to deal with. They have to go in manually and toggle this setting each time they take on and off their gloves. And it's been a universal problem. It's not just with tablets that Zebra makes, it's been a universal problem across tablets, across many manufacturers. As a matter of fact, all rugged tablet manufacturers. And so, up until a few weeks ago, there hasn't been a way to auto sense and auto detect and handle this back and forth toggling seamlessly without any user interaction. So, people are probably wondering and really excited about this new technology and applauding the work that my guests today have put into bringing this technology to life. So Kevin Rennis from SigmaSense and Larry Stone from Zebra are my two guests today that are going to be talking about this really cool technology that now exists that addresses this pain point for our frontline workers. So you two have finally addressed, this really major friction point for frontline workers. We often find these workers in utilities, telecom, manufacturing, and even in the public sector. And it seems like such a small thing to worry about, but I think the impact is huge and significant than maybe a lot of people realize. So yeah, can you kind of say a few
Yeah,
things about that around this
let
seemingly
me let me let
small
me just let me
issue?
just expand upon what you said.
Sure.
So first of all, we like you mentioned, we have mode switching in our previous products, computers, and there's actually multiple mode settings. So there's glove use, there's uh, water on the screen use, and also passive stylus use. So we have basically four different modes. So there's a standard mode, there's a water on the screen mode, there's a glove mode, and a passive stylus mode. And with the new SigmaSense technology, we are able to avoid having to set any of these modes. And one of the important things to remember is if you're wearing gloves, you go to tap the screen, nothing happens. So you have to take your glove off, go to the mode setting area, and then change the mode, with your bare finger, could be freezing out. We got to do it with your bare finger, and then you can put your glove back on and it'll work. With the SigmaSense technology, you don't have to worry about any of that. It just works in standard mode for doing all of these use cases. So you want to say anything about that, Kevin?
Yeah, no, that's always a great example that we like to hear about, because let's say it's raining and you want to interact with your touchscreen. Well, it's already wet, but you may have it in standard mode, so you can't actually work through the touchscreen because it's already wet. So you have to go somewhere, dry it off, use your finger, switch it to water mode, and then you can start using it again. Prior technologies for touch were quite cumbersome for literally anyone in an industrial or commercial environment where, Tommy, as you were saying, there are these other environmental factors. It might be cold, they have a glove on, it might be wet, they have to work, let's say, in multiple environments in a given workday where sometimes it's cold, sometimes it's not, sometimes it's wet, sometimes it's dry. So the semiconductor technology that we developed, that Larry and his team incorporated into the Zebra product, makes all that just work.
Right, right. So, Kevin, you and your team, you basically use, it sounds like you some type of AI technology that automatically does the sensing, and the
Yeah.
users have to do nothing, just kind of grab the tablet with whatever,
Yeah.
bare hands, gloves, and it just knows exactly what's going on, right?
Yes, it knows it, and I'll describe that a little bit. And as always, I wish my cell phone did that, because if your phone's wet, it doesn't work. If I had a glove on, it wouldn't work. And so Zebra is first in the world to exploit this technology, and it really is one of those times that sometimes we complain, oh, there's all this tech and how does it all work and how do we maybe benefit or not benefit? For somebody that actually relies on the work product that they're getting from Zebra to do actual real work in these different environments, the technology is actually helping them with a smoother workflow because they're not taking gloves on and off, as you said, Tommy. Larry mentioned water. And we were able to achieve that because of the way we designed fundamentally a new touch chip. So we do the chip, and so we're reading the sensor and getting this intelligence into the system is fundamentally all about getting better data from, I don't have a tablet in my hand, from the device. How do you get better data off of this interaction of a touch, whether it's a glove? Thank you, Larry. Whether how do you get better data off of that device with the human interaction to then make smarter decisions? So that's what our chip does, is we have extremely high data rates. Just look at where the touch point is. We look at the whole screen. So we're imaging the entire screen all the time, 300 hertz at 300 hertz, which is 3 milliseconds every time we're looking at the entire surface. And we have a lot of very sophisticated algorithms that we've characterized and built that we can automatically detect as someone is approaching the screen and they make contact to it, whether it's a finger, glove, is it in a water condition, is it dry, is it stylus. So all of that only happens when you can get more data faster to train the chip, if you will, to be able to respond quickly and say, oh, it's glove now.
I'd like to just say a couple of little things that from our experience with going through the development of the of SigmaSense, we actually started out with doing a prototype version, and that used one of their earlier chips. And with this prototype version, SigmaSense, in their standard single mode, their competition chips in glove mode, water mode, passive stylus mode, when they were set to those settings. Okay, so basically SigmaSense technology had a better touch experience in all various modes using a single mode. So we saw early on that this technology was really a game changer. So
And it sounds like not only did we kind of solve this problem of, the manual switching and being able to do the auto switching, I hear that, it also, in the process of solving this problem, we also were able to address the issue that often comes up with responsiveness when the device is wet, right?
Yeah, as Larry mentioned, one of the things that drove us from a technology standpoint is things like machine learning or AI are only as good as the data that they receive. And or what like to say, you have to feed those models, those algorithms with lots of data very fast to be able to get them to respond appropriately in whatever interaction we're talking about. And here we're talking about touch. So the other aspect of that is as you're interacting with the various icons on the screen, is it fast? Is it slow? Are you accidentally tripping two actions when you only wanted to trip one action? And so the fidelity of the data and understanding how that frontline worker is interacting with the device exactly, and that it's very responsive in any environment, just makes in many cases for, depending on what their workflow is, it's a mission critical thing that they might be doing, and it has to work. It has to work all the time, and it has to work in every condition. And that's what kind of motivated us as a semiconductor company to build a better sensor. And this is the touch IC chip sensor to work in all these different environments automatically.
That's excellent. So Larry, how did you and your team kind of, catch wind of what SigmaSense was doing with this,
yeah,
technology and their chips, and how did you all connect Zebra and SigmaSense?
so I have history with some of the people that work for SigmaSense, and I've had long-standing relationships with people in their company. They are local here in Austin, so it was easy to find. Actually, a close friend of mine was working as a consultant for their company, and he would tell me about their technology. And I'm like, I don't know if I'm going to believe this stuff. When they got to the point of having something that is manufacturable and producible, I wanted to take a look and see if it was for real. And they have a whole bunch of really cool demonstrations they have in their office that was really exciting to see. And it looked like they were on the verge of doing something really big. And the more we looked into it, the more real it got. So organization here, the tablet organization at Zebra, has a long history of introducing new technology. Like, we were one of the first rugged tablet computer companies to introduce Corning Gorilla Glass. We like to introduce new technologies, certainly if it's well baked, and ensuring that SigmaSense was well baked and ready to roll was really the biggest concern. And it's a huge undertaking on their part to make the product ready for mainstream, but they are there. And we introduced it into the ET6 Windows tablet here, and we're ready to roll. So
Yeah, that's great. And, talking about Zebra being the first to introduce new stuff. So kind of here we are with Zebra being the first device OEM in the world, really, to market a rugged Windows tablet, like you just shown, with a touch screen that can automatically detect the type of touch and, do the settings management in the background without any kind of manual user intervention, and works great when it's wet. So that's a
yeah,
pretty
I can
pretty
tell you,
exciting first.
yeah, a really good use case. We have customers that are, like EMT people. Um, their first and only priority is to the patient.
Right.
They don't have time to wait around for things like the touch sensor to, tapping the screen. They think something's wrong with the computer if they can't get to it right
Right.
away. They have a life critical situation. They need it working right away. So for examples like that, this product is absolutely perfect. And yeah, I'm
Absolutely.
glad we came across that.
That's excellent. So yeah, just my next question is around the capability and why it took this long to get this kind of technology baked into tablets. So is it been that this just wasn't possible without AI, or did we have to wait for AI to mature for this to become a reality? Any thoughts around why it took this long to get this
Yeah.
feature and capability exposed in our technologies?
Yeah, I'll have a quick comment. I'm sure Larry will as well. In this case, from a touch IC, and I keep saying touch IC, just focus on we're doing a touch chip, and we actually worked with the existing touch sensor that Zebra already had, so we didn't have to change anything on the engineering side of the actual sensor. All that had to be done is pop out one chip and pop in another chip. So that in itself is a whole story relative to the capabilities of the chip. But the big shift in touch semiconductors is the fact that 90% of our chip is digital, and there's something called the analog front end. Everything we do in the digital world, we're analog human beings. Space, air, acoustics is how do you get analog to digital? How do you convert the real world, which is analog, into ones and zeros in the digital world? So we have a very sophisticated analog front end, and that's about 10% of the chip, and the rest of the chip is digital. And that's where we're able to put in all of the algorithms, the memory, the DSPs, which are called digital signal processors. So we have 128 channels. What that means is we have 128 basically frequency analyzers that are looking at the entire screen, backed by powerful digital signal processing and our powerful algorithms that take that real world analog signal, turn it to digital, and then put intelligence into the digital signal through very fast data reporting all the time. So that 300 hertz I was talking about.
And one of the big selling features that SigmaSense kept telling us is they have really good signal to noise ratio. So basically, it means that when you touch the screen, any noise in the environment is way lower than the signal from the touch. So that really gives them a better eye on what's going on the screen, not any distractions from other sources. So that really helps the situation as well.
Particularly with some of the environments Zebra customers are in, they're from an electrical standpoint, well, EMF, electromagnetic standpoint, they're very noisy. Meaning whether you're in a car, whether you're in a refrigerator, whether you're in a warehouse with forklifts going up and down and all the rest. So that from a electronic standpoint, they're very, very noisy. So as Larry was saying, in this conversion of analog to digital, which every electronics device needs to do, you have to know that you're looking at the correct signal. So you have to get rid of all the noise you don't care about and make sure you're picking up the signal you want. And then that's what Larry was saying. That is a key part of our capability, is that signal to noise ratio, which is it called, where we can have super noisy environment, all this stuff going on, but we know that's the touch through water, or that's the touch with the glove on. And we can, because we're digital, 90% digital with very smart algorithms, we can make that distinguish and pick up the correct signal.
Yeah. Now I'll say, through the development, it wasn't always rosy. We had to make some improvements on palm rejection and some other areas that really helped to improve the product. So it's been really a growing together deal where we gave them our requirements, and they had their already proven out requirements of their own, and we blended them so we have a good product that meets both of our needs.
Yeah, I would
Right.
have to say, Tommy, and I say this very sincerely, both personally and on behalf of our company, we're very grateful that Larry, took a chance on us. We're an emerging technology company here in Austin, Texas, and we had this, newfangled idea on how to do touch sensing. Larry had the vision to see, hey, we could actually go exploit that. So Larry and his team and the team at Zebra around the world, with your global teams and procurement and engineering and supply chain, really made us a better vendor, made us a better producer of the product, because yeah, we thought we had palm rejection, and Larry's like, no, it's got to look like this.
Right. That's great partnership. So
Yeah.
do you envision this being, the standard going forward? Are you seeing interest from others approaching you all to incorporate this into their technologies that they're creating too?
Yes, I think the touch market, the touch world, not to be too grandiose about it, will never look back, because once you've kind of seen this experience and actually felt it, I mean, it's, again, I'll use it on a consumer device basis. You know, people want to know that the device will just work, and particularly with frontline workers that Zebra addresses so well, nobody's going to ever want to go back, quote, to the old days of, where's that knob I got to go turn? Oh, I can't even turn the knob because I have my glove on. let me go take the glove off so I can actually put it in the mode I want and then put my glove back on, type of thing.
Actually, the other good demonstration that they do is really large screen signage outside of buildings. You've got these big digital signs, and they were outside, and they have their chips in these, so you can do touch even if it's raining. And they're the only technology really that can do, these larger screen touch screens with being able to drive the capacitive signal across the whole screen well. So that's a little extra plug for it.
You can see those large public information displays.
Yeah, those Wayfinder, you're here
that's
at the
our
malls and
touch technologies.
hospitals.
If it's
airports.
interactive and outdoors, 13
Right.
millimeters bulletproof glass.
Yeah,
Larry mentioned
these guys should lock the market on that type of.
Right.
Yeah,
So,
we did. And the other thing I'll mention, Tom, just real quick, is even as we're using whatever devices we're using for this podcast, it's all about the human to machine interface.
right.
HMI. How easy, how fluid is it? How natural is it? And as Larry and you were both describing, with this type of automatic detection, it really fundamentally changes the HMI for touchscreens. And I do think and I think you were about to say earlier that it's a sea change. I do think it is going to be a sea change. People will want touch HMIs, human machine interface, to work in this way for any device that's interactive.
Right.
And we believe more and more screens, as Larry pointed, whether it's outdoor digital signage or others, people expect interactivity when they see a screen, and they'll go up to it and go, oh, a kiosk, a point of sale, and Zebra certainly is involved in those areas. They expect it to be interactive.
Right.
Every other screen they look at is interactive. So we think it'll be quite a significant shift.
Right. Yeah, and in terms of the technology, I think those mall signages and the Wayfinder type things on the bigger screen, did we have to kind of look to optimize it for like this smaller screen, this tablet form factor screen, or was it basically the same kind of technology kind of just rolled right over into that smaller screen size type form factor?
I can take this a little bit. It's a new chip that's only 125 channels, which was perfect for our screen size.
Got it.
So it can do up to what size? Maybe 17-inch, maybe.
Yeah, a little larger. Yeah.
Mm-hmm. Yeah. So yeah. But it was actually the chip that enabled us to move forward. The older chip had some power consumption problems and stuff that for mobile products wouldn't work well. So this really gave us a good avenue to move forward.
As Larry said, this SDC 300, as we call it, was fundamentally a new chip packaged for lower power, smaller form factor for tablet devices. whereas our earlier generation chips were not as effective, were really not applicable for tablet devices because they were in things that you had plugged in all the time.
Right. Exactly.
So
Got it.
they
Yeah.
were not optimized for something you would carry around, and now we have something optimized for what you would carry around.
That's great. I imagine, if these tablets were in cases and such, would they still work the same, or, would that responsiveness
Yeah,
still be the same, whether it's bare device or
we
encased
often
in
have
a
people put screen protectors on the
screens on
front,
top of it? Right,
on
right.
top, and there's absolutely to it all with that.
Perfect.
It works just as good. Um, like Kevin was saying, you could put, I think you had a sample of 13 millimeter thick.
13 millimeter thick glass.
He's had on
touchscreen.
their digital signage stuff. They can demonstrate,
Yeah.
touch, and you can actually do glove use through that really thick glass.
Right. Yeah, that's great. How about from a, life cycle standpoint, these tablets, they're built to last a really long time. Are there updates that need to be made along the way, or does this technology just kind of, stay put throughout that, 5 to 10 year life cycle that's typical for these types of rugged tablets?
Yeah, the sensor film behind the glass is the same as any other touch sensor. So there's no issue with that. And obviously the chip is similar technology to other chips in the market. Like Kevin said, though, it's got a very small analog front end and much bigger digital back end. The digital, I think, is probably the more reliable. So they probably got a leg up from that perspective. So,
and also from our end, it allows us, let's say, if there might be something in the future that comes up that, let's say, in discussions with Larry and the Zebra team, and it's something we can do in software, we can update the chip because it's 90% digital. So we could put additional capabilities into the chip purely by software.
Yeah, it'd be a firmware update.
And firmware update, thank you. Firmware update, and wouldn't have to make any hardware change.
That's great.
Yeah.
That's awesome. Well, I mean, this is, a really great thing to see for how AI is assisting, frontline workers. It may not be the typical traditional AI assistance that most people will think of, but this is a very practical one that addresses this really friction point that's, can be a hassle really in the workflow of the frontline workers. So this is it's really, really great to see. And congratulate both Kevin, you from SigmaSense on developing this technology, and Larry, from the Zebra side for the vision to see this and included in this really cool product that we've just come up with. Yeah, it's awesome. Anyways, before I let you go, is there anything else you want to add for our audiences to know about this really cool?
Well, I would like to add one thing. That because their technology is so good, it does lend us the possibility of looking at lower price, lower cost sensor films, and actually taking advantage of some of their other features, like potentially more capacitive buttons built right off of their touch sensor and stuff like that. We're just kind of beginning to think about what more we can do with it. So certainly driving costs out is always a big thing in our company. And, I think the sky's the limit with this thing. So
that's great.
Well, and we appreciate, again, Larry taking that step with us and having the vision to do so. We're super excited that we have the product in the market, and we look forward to a long-term strategic relationship with Larry and his team and Zebra.
That's great. That's really exciting. Yeah, but again, thank you, Kevin and Larry, for joining me on this episode. Again, congratulations on this incredible milestone that we've reached with this joint technology that we've put together in the new product we just released. And for folks that want to learn more about AI-enabled touchscreens or Zebra tablets in general, our website is a great place to visit to check out all the great things we have available and offering to the industry in the frontline workers, again, to address pain points, address challenges, and close gaps. So excited for this new product, excited for the partnership, and for what else is to come, really. I think it's a great start to many more cool things that we can bring to market. So again, thanks, Kevin. Thanks, Larry. It's good talking
Thank
to you
you.
guys.
Thank
Have a
you.
great one.
All
Thank
right.
you.
Yeah. Thanks.